Mathematicians quite often have to deal with quantities called surds. A surd is just a number which is written using a root sign. So for example, we might have a square root, as in these two cases, a cube root, like we've got here, or it might be a fourth root, a fifth root, and so on. If we take a look at these numbers, we can find that with some of them we're able to reduce them to a single whole number. For example, the square root of 9 is quite simply 3, because 3 times 3 equals 9. It's the definition of a square root. However, if we look at this one, there isn't a single whole number that we can multiply together to give us 5. Our calculators will show us that a number which is very close to the value we need is about 2.236. If we take more digits, we can get a closer answer, so that's an even better approximation to the answer. We could take a few more, but actually we'd have to take an infinite number of decimals after the point to give us the exact answer. That's not practical. We don't have machines that can store to that accuracy. The best we can do if we have a calculation is to simply write this value as the square root of 5. This is like an abbreviation. Here's another example. If we've got the cube root of 1000, well, this reduces to a single whole number. The answer to this is 10, because 10 times 10 times 10, or 10 cubed, is equal to 1000. However, if we take the cube root of 100, there isn't a single numerical integer which will multiply to give us 100. The nearest we can get is if we write down 4.64158, and we keep writing digits down. So if we take this number and we multiply by itself 3 times, then we'll get 100. However, instead of doing calculations where we have to manipulate all of that, it's much easier to leave this in surd form. So from this list we find that this is a surd and this is a number in surd form.